for joining me on Fascinating Frontiers, episode 97, coming to you on June 10th, 2026. Here's what's happening in space and science today. A galactic wind driven by early universe collisions is stripping star-forming fuel so fast it may explain why so many massive galaxies went dead. Astronomers detected a powerful outflow triggered by galaxy collisions that rapidly removed gas needed for new stars. The wind leaves massive galaxies on the brink of becoming permanently dead, addressing why more such quiescent systems appear than models predicted. Observations show the mechanism operates through repeated mergers that inject energy and drive material outward at high speed. This process offers a direct way to quench star formation without waiting for slower internal exhaustion of fuel. Follow-up spectra from larger samples will test how common the effect was across cosmic time. If the Milky Way were scaled to the size of a dinner plate, a typical early universe galaxy collision would span a city block and release energy equivalent to billions of supernovae detonating at once. The resulting wind slams into surrounding gas at thousands of kilometers per second, sweeping up and heating material until it can no longer collapse into new stars. Telescopes have measured outflow speeds exceeding 1,000 kilometers per second in galaxies seen when the universe was less than 2 billion years old. These winds can clear an entire galaxy's reservoir of star-forming fuel in just a few tens of millions of years. Yet we still do not know exactly how much of the expelled gas falls back later versus escaping forever into intergalactic space. Now shifting to future telescope capabilities. A new study modeled how the planned NASA telescope would detect atmospheric signs of life on a planet resembling Earth billions of years ago. The analysis focused on ozone, oxygen, and methane combinations that would stand out against the background of an early Earth-like world. Researchers ran simulations across different viewing angles and cloud cover to gauge detection. The work helps set performance requirements for the mission's instruments before hardware is finalized. Next steps include refining the models with additional atmospheric scenarios expected from upcoming exoplanet surveys. On a different note, today marks the birth of a key figure in solar physics. Theoretical astrophysicist Eugene Parker was born on this date in 1927 and later proposed that the sun continuously emits a stream of charged particles. His 1958 paper described a supersonic solar wind that would reach Earth and the outer planets. Mariner 2 confirmed the prediction 4 years later, validating the first detailed model of the heliosphere. Parker's framework remains central to understanding how the sun shapes space weather and protects the solar system from galactic cosmic rays. Ongoing missions continue to test refinements of his original equations. Turning to commercial developments in orbit, a Los Angeles startup raised $5 million to demonstrate computing hardware in space next year. The company plans an eventual constellation of more than 100,000 orbital data centers to serve AI workloads. The demonstration will test power, thermal, and communication systems in the radiation environment above Earth. Success would open a new commercial use for low Earth orbit beyond communications and Earth observation. Additional capital rounds are expected once the first hardware reaches orbit. Next up is an expansion of satellite tracking. The company deployed a transportable tracking radar in the Indo-Pacific region to maintain continuous coverage of active spacecraft. The sensor is designed to follow objects that change orbit, filling gaps left by fixed installations. Continuous tracking supports collision avoidance and helps operators understand the behavior of maneuvering satellites. The system joins an existing global network that already monitors thousands of objects daily. Further mobile units are planned for other high-traffic regions. Shifting to propulsion contracts. Spanish propulsion startup Arcadia signed a contract to supply thrusters for a satellite under construction by Reflex Aerospace. The engines will enable orbit adjustments and end-of-life disposal for the new spacecraft. Integration testing is scheduled ahead of the planned launch window. The deal marks another European commercial customer for the small thruster specialist. Additional contracts are under discussion with other satellite builders. Interest is also rising in alternative launch methods. Crowded land ranges and military concerns are prompting renewed study of offshore launch platforms. Proponents argue that mobile sea platforms could ease scheduling pressure and provide resilient options during conflicts. Engineering studies are examining stability, safety zones, and regulatory pathways for floating pads. Several commercial firms have begun preliminary design work on vessels that could support medium-lift vehicles. A demonstration launch from a converted ship remains a near-term goal. On the technology side, NASA is testing a compact radar system. Engineers at the Jet Propulsion Laboratory built a multi-frequency radar that fits on a small satellite and probes clouds at 3 simultaneous frequencies, between 36 and 240 gigahertz. The instrument targets a wide range of droplet and ice particle sizes to improve precipitation estimates. CloudCube will fly on a future CubeSat mission to collect data over both land and ocean. Early ground tests show the compact design maintains sensitivity comparable to larger airborne radars. Flight data will help refine algorithms for future operational missions. Another propulsion advance comes from MIT. Researchers developed a compact electric propulsion system sized for CubeSats that could reach the red planet. The engine uses a novel propellant and electrogeometry to achieve higher efficiency than current small satellite thrusters. Laboratory tests demonstrated sustained operation at power levels suitable for interplanetary trajectories. Mission designers are now modeling trip times and payload capacity for a Mars transfer. A flight demonstration on a near-Earth mission is the next planned milestone. Europe is also examining supporting infrastructure. Satellites now underpin timing, communications, navigation, and climate monitoring, yet Europe lacks sufficient ground systems to support growing fleets. The article examines gaps in data processing, cybersecurity, and spectrum management that could limit future missions. Policymakers are considering new investment in shared infrastructure to keep pace with commercial growth. Without upgrades, analysts warn that launch capacity alone will not deliver full strategic benefit. A series of workshops will gather input from operators and agencies this summer. In a human interest development, a student has refined search targets. An Ankara student created a catalog that removes 1.75 million stars unlikely to host detectable civilizations, leaving a shorter target list. The filtering system uses stellar age, metallicity, and galactic position to prioritize candidates. The resulting public catalog is intended to help radio observatories allocate scarce observing time more efficiently. Early tests show the method reduces false positives from young or metal-poor stars. Larger surveys will incorporate the list in upcoming observation cycles. Turning to a proposed lunar mission, Japanese researchers designed a compact 10-ray instrument that could survey the entire moon from a single satellite in roughly 2 years. The telescope would measure elemental abundances across the surface to clarify the moon's formation history. Current sample return data cover only a few locations, leaving global questions unanswered. A small satellite mission could fill that gap at lower cost than previous orbital spectrometers. Mission concept studies are now under review by Japanese space agencies. The proposed single satellite X-ray telescope for mapping the moon would measure elemental abundances across every major terrain in roughly 2 years. Current samples from Apollo and Chang'e missions represent only a handful of sites, leaving global questions about the lunar mantle and crust unresolved. By detecting characteristic X-ray fluorescence from orbit, the instrument could distinguish between competing models of how the moon formed after the giant impact. Data would also help identify resource-rich regions for future exploration. Could a global elemental map finally settle whether the moon's far side crust differs fundamentally from the near side? Next is a major upcoming conference. The world's largest space science meeting will gather in Florence from 1 to 9 August 2026. Organizers expect thousands of researchers to present results across planetary science, astrophysics, and heliophysics. The assembly includes dedicated sessions on upcoming missions and data analysis techniques. Early registration opens later this month. The event returns to Europe after the previous meeting in Busan. Educators are also updating classroom resources. Educators in the Globe Mission Earth project worked with NASA Langley to improve how students use satellite land cover data from MODIS, Landsat, and Sentinel-2. the community of practice developed new classroom activities that match student observations with orbital measurements. The effort aims to strengthen links between ground-based citizen science and satellite records. Participating schools tested the materials during the 2025 to 2026 academic year. Revised modules will be released for wider use this fall. Finally, a look at one of Jupiter's moons. The outermost of Jupiter's 4 large moons shows an ancient, heavily cratered surface that has changed little since formation. Its distance from the planet reduces tidal heating compared with Europa or Io, preserving a record of early solar system impacts. Spacecraft images reveal bright, icy plains interrupted by dark, cratered terrain. Future missions could measure its interior structure to test whether a subsurface ocean exists. Callisto's stability makes it a key reference point for understanding the Jovian system's evolution. Keep an eye on the next round of funding announcements for orbital data centers, as follow-on tests could determine whether the concept moves beyond the initial demonstration. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow, and if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Environmental Intelligence a listen, the Environment and Climate Policy Brief for Canada. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly